Hi math class, I just want to take today to do some review questions, and tomorrow you'll have the unit assignment available to you. All right, we have one more unit after this. Everything's wrapping up real well. So, first question here, I want to use log laws to simplify and evaluate. All right, so remember when you see log by itself, that's base 10. You don't need to write it, but that might help us here. When you're adding logs, what we're going to do there is multiply what's after the log. So this is going to be 20 times 10. Okay? And then I'll subtract log 2 here. You could also do it all at once. You could do 20 times 10. When you're subtracting logs, you actually divide. Okay, but let me just sort this out first. This is going to be log of 200 minus log 2. Okay? Again, when you're subtracting logs, you can make it one log if it has the same base, and you just divide what's after the log. So this is going to be log 100. Okay, just a reminder, log by itself is log base 10. The answer to a log is what the exponent would be. So it's 10 to the power of what equals 100? And that just equals 2, okay? Because 10 power 2 equals 100. All right, let's do a couple more. So I messed up writing this one. This is just a big subtraction, just so we're aware of that. Let's do this one all at once. So it all has the same base. It's all log base 5, which means you can combine all these logs into one. Subtracting means you divide. Adding means you multiply. I can write it like this. So it's going to be log base 5 of 750 divided by 6. Okay. When I do that on my calculator, I get 125. Okay, and we can actually evaluate that. Again, you're looking for the exponent. 5 to the power what equals 125? If you don't know what that is off the top of your head, I don't blame you. What you can do is just try some stuff. So I know 5 to the power 1 equals 5. Try 5 to the power 2, 25. 5 to the power 3, we got our answer. Okay, so the answer is that exponent, 3. That looks good. Got a couple of simpler ones here. These two numbers don't jive. There's no number that 3 to the power of will equal 11. It's going to be between 2 and 3. If you have these guys that don't get along, just remember you can divide them as their own logs. You call that the change of base rule or law. Okay. And just do that on your calculator. Do log 11 divided by log 3. If you don't close this first bracket, it will give you the wrong answer. So I can just write that, 2.183. Just a heads up, on a unit assignment, I might put all the responses just in terms of logs. So this might be just all I want from you. Okay, so sometimes I just want the log expression, not necessarily the number. All right, I got another one here. There's two ways you can do this, and it doesn't matter what you want to do. I just wanted to show you one with an exponent. If you have an exponent inside a log, you can pull it out. This becomes 2 times log 6. Okay. And then this guy you can do just like the previous example. That's going to be log 6 divided by log 5. Okay. So I'll do log 6 divided by log 5. Then I'll multiply by 2 at 2.23 or 2.227. Just a heads up, you could have absolutely just simplified what's inside the bracket and done it that way. I just wanted to remind you of the law or the rule. If you have an exponent, you can bring it out in front. We'll be using that a lot in our next example. So if I do log 36 divided by log 5, I get the same thing, 2.227. Okay. So in a question like this, you could do it either way, but just a reminder, your answer might be one of these two. Okay, in a multiple choice, I might leave it in logs. I like doing that. All right, the newest stuff. So using logs to solve an exponential question. Let's just focus on this one here. Reminder of the steps. You take log of both sides. Anything that's an exponent can come outside the log. Then to get x by itself, I just need to divide. In questions like this, I'm going to leave the answers in just terms of logs. If I put the decimal, it's really easy to just pop the decimal in to see if it works, which is okay. I might have one like that. You're allowed to do that if it's possible. But if I leave it like this, it kind of forces you to actually do the steps. All right. So that one's not too bad. These are the ones that I think give us some grief when there's more stuff in the exponent and there's exponents on both sides. But the steps are the same. We just run into some algebra. So this will be on the unit assignment, but I'm not going to put like 5 of them on there. I'll probably put 1 on there. All right. So everything's the same. Exponents go out in front. When I have like an addition or a subtraction, I put it in brackets because that just reminds me that I have to distribute those terms. Okay, so x plus 2 times log 2, that's actually equal to x times log 2 plus 2 times log 2. Okay. Now what I'm going to do is gather my like terms. I'm actually going to bring it over here though. So it's going to be x log 2 minus x log 3. Okay, so I just brought this one to the other side, and then I'm going to bring this term without any x's to the right side. It'll become negative. And then if I factor an x out, this is what it looks like. To get x by itself, you'll just have to divide. This is good. One other thing you could do is multiply the top and bottom by -1, and it'll just look a bit nicer. So if I multiply the top by -1, this will become a positive. And when you're subtracting things, if you switch the order, that's multiplying by -1. So I'm just going to switch the order of that subtraction. This looks a little bit nicer than that, but they are the same. If you can take it this far, I'm really happy. I just wanted to show you this extra step. Okay, so just a reminder, that's a lot of algebra. That's definitely as difficult as anything's going to get. And there'll be one of them like it on your unit assignment, but I'm not going to make you do this for hours on end.